Hi team, periodical friends, here we are again. I need your book open. I need you on page 189. We've got some vocab, and it's going to be just as easy for you to read it out of the book as I say it, and then it'll you can write it actually in your on your note sheet as well. We're talking about least common multiple, better known as LCM. And I know you've done this before, so we're going to add it to our T-chart. It's going to be on the other side of GCF. But let's make sure that we understand the vocab that goes with it. A multiple of a whole number is a product. So we're talking about multiplication here. A product of the number, whatever number you're starting with, and any non-zero whole number, because remember 0 is a whole number, so we have to exclude him, a whole number. So for instance, if I'm starting with the number 3, the first multiple of 3 is 3 times 1, which is 3. The second multiple, 3 times 2, 3 times 3, 3 times 4, on. Common multiple. The multiple, if you have 2 or more numbers and they have a multiple that they share, then that's called, of course, a common multiple. So that is a multiple that is shared by 2 or more numbers. And again, you can copy this right out of the book. And then that takes us to least common multiple, LCM. So this is the smallest common multiple. Multiple that is shared by 2 or more numbers. So in thinking about this, is there a greatest common multiple? Well, I don't think so, because multiples never end. Can't you just keep going? 3, 6, 9, 12, 15, 18, 21, yada, 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 yada. Never ending. We'd be 100 years old and still having more multiples that we can list. So if every number can have an infinite amount of multiples, then there is no greatest common multiple, just the smallest, the least common multiple. So I'm going to go ahead and point out these rules here for finding the GCF and the LCM. Of course, we've done a lot of work with the GCM, and we start with the prime factorization. We know that, of however many pieces you have. And for the GCF, we use only bases that are in all of the prime factorization boxes, only in common. And then we use the lowest exponent on that base. So the LCM is different. It is going to use every single base in our prime factorizations, even if it's only in just one. It doesn't matter. We're going to use every base. We're only going to write the base once if it appears more than once in one prime factorization. And we're going to use the highest exponent. So this is like totally different. Totally different. And you might think you're going to end up with a larger number generally for LCMs than GCFs, and that's true. All right, let's just work them. That's how we learn how to do it. So we're going to start with the prime factorizations just like we did when we were doing GCF. So I happen to know that 16 is 2 to the 4th because I memorized that, and I hope you have too. 24, maybe I'll start with 12 times 2, which is 6 times 2 times 2, which is 3. I'm going to prove it. 2 times 2 is 4, doubled is 8. That's not right. I've done something wrong. 12 is 6 times 2. 6 is 3 times 2 times 2. 3 times 2 is 6. Oh yeah, doubled is 12, doubled is 24. I lost my target number. That's 2 cubed and 8. That's a 3. Box it up. Please box these prime factorizations. Now we're ready to make the T-chart. I'm going to have GCF over here. I'm going to have LCM over here. I don't care which side you put yours on, but I would be consistent if I were you because you'll get confused if you don't. So for the GCF, let's go back to 4.2. I'm looking to see what do they have in common. Well, they have a base of a 2 in common. What exponent do I put on the 2? I put the lowest one for GCF. So that is a 3. That's a 4. So the GCF is going to be 2. The base is only written once. Even though it's here and here, we write the base once. 2 cubed is 8. My GCF is 8. LCM. Let's go back to LCM. The rule, use every base in the prime factorization. So I see a 2. That's good. I'm going to write it down. There's a 2 here, but I've already got it written down. I didn't write this right, did I? This is 2 cubed times 3. All right, so 8 times 3 is 24. So I see a 2, and I see a 3. There is not a 3, I know, in this prime factorization, but for LCM, I don't care. It doesn't have to be in every single prime factorization, just in one. And now I go and I use, you can see what this says, use the highest exponent. So I see 2 to the 4th, and I see 2 to the 3rd. I'm going to put a 4. And I'm going to use the only exponent that I have on 3, which is 1. 2 to the 4th is 16 times 3, and my LCM is 48. So you can see my LCM is much larger than the GCF in this case. Let's do another example. Start with the prime factorization. 9 times 2, which is 3 times 3 times 2, or 2 times 3 squared. Please write them in numeric order. If we have variables, they come on the back end. 9 times 3, 3 times 3 times 3, or 3 to the 3rd power. Once you have all of your prime factorizations done, you're ready to make the T-chart. GCF, LCM, I'll start with the GCF. These are the ones they have to have the base in common. So they have a 3 in common, and I'm going to take the lowest exponent, which is 2. So the GCF is 9. The LCM, I go back and I take every single base I see that's different. So there's a 2, got him. There's a 3, got him. And over here, he has a 3. I've already got the 3 written down. So now I'm just concerned about my exponents. I've got 2 to the 1st. Okay, 2 to the 1st. And I've got a 3 squared and a 3 cubed. So I'm going to take the highest exponent I see, which is 2 times 3 cubed is 27. 27 doubled is 54. I'm going to do another example here. We're going to do the same thing. You might want to pause the video and try this on your own and see if you end up with what I have. 8 times 3, which is 2 cubed times 3. And I'm done, because 8 times 3 is 24. 36, you can either do 6 times 6 or 12 times 3. So that's 4 times 3 times 3. So I've got 3 squared, and that's 2 times 2. Sorry, I made the mistake of 4s. So I've got 2 squared, which is 4, 3 squared, which is 9. 4 times 9 is 36, so I've proved it, and I'm ready to make the T-chart. All right, so GCF, we go back to only the ones they have in common. Well, they've got both bases in common. They've got a 2, and they've got a 3. And I'm going to put the lowest exponent I see. So this is 2 squared, and this is 2 cubed. I'm going to put 2 squared on it. 3 is to the 1st power there, to the 2nd power here. I'm going to put a 1 on it. That becomes 4 times 3. The GCF is 12. LCM, a little different. Again, I still have the bases of just 2 and 3. There's nothing extra, but I'm going to put different exponents on it now. 3 and 2. 3 is higher. 3 to the 1st and 3 squared. 2 is higher. So that becomes 8 times 9, which is 72. And that is going to be the GCF and the LCM for that one. I want you guys to try number 4. I want you to pause the video, try number 4, and then I think we're 10 minutes in. I think I'll just do a brand new video starting at number 4. So why don't you do number 4, come back in, and then we'll do the rest of the examples. We'll pick up some monomials with some variables in the next video. So there is another link, another video to watch. Bye.